Let's find the perimeter and the area of this shaded region, and when necessary we'll use 3.14 as an approximation for pi. Since we're asked to find two things, we'll start with finding the perimeter. The perimeter is the distance around the area that's shaded. So in order to find the perimeter, let's think of walking around the area of shading region here. We walk across here, through here, across here, and through here. The key to finding this perimeter is to notice that this length is given, and this length is the same length, and each of these curves is half a circle. So if we add 18.6 kilometers, 18.6 kilometers, and 2/2 of this circle circumference, which is a complete circle circumference, the 2/2 together, we would have the perimeter of this region. To write it in a different way, we have the top length, I'm going to call it, plus the bottom length, plus the circumference of the circle, the 2/2 put together. Now the top length was 18, the perimeter equals, the top length was 18.6 kilometers. The bottom length was 18.6 kilometers. Plus the circumference of the circle. The formula for circumference is 2 times pi times the radius. So I'm going to write 2 times pi times the radius. Being very careful, the radius is not the diameter. The diameter is 9.0 kilometers. The radius then will be 4.5, or half of 9.0 kilometers. So I write this as 4.5 kilometers. In this step, I'm going to substitute 3.14 for pi, so use an approximation sign. And 18.6 plus 18.6 is 37.2. So I have 37.2 kilometers plus 2 times 3.14 times 4.5 kilometers. And now I take 37.2 kilometers and I multiply 2 times 3.14 times 4.5, and I get 28.26 kilometers. Finally, we add those lengths together, and adding we have 65.46 kilometers. What I have found is the perimeter, or the distance around this region. I'm also asked to find the area. The area is a totally different idea. It's the amount of area that's shaded inside the region. In order to find that, I need to see this region as a combination of shapes for which we know the formulas for the area. And what I see, if I would close this off down here and down here, I see a large rectangle with length of 18.6 kilometers and a width of 9.0 kilometers. Out of that large rectangle is cut half a circle on the right and half a circle on the left. Combined together, I have one large rectangle with one entire circle cut out. So for the area, I should be able to write this as the area of a rectangle, the large rectangle, minus that area of a circle. The key to these problems is being able to see those shapes inside a figure like this. The area of a rectangle is the length times the width. So the area would equal 18.6 kilometers times 9.0 kilometers. I want to subtract the area of the circle. The area of a circle is 2 times pi, pi times r times r. Again, we do not want to use the diameter. We want to use the radius, which is 4.5 kilometers. So I use 4.5 kilometers times 4.5 kilometers. On my next step, I'll substitute 3.14 for pi. I have 18.6 times 9.0 times kilometers, or I can write that as square kilometers, minus 3.14 times 4.5 times 4.5, and that's also square kilometers. Now, when I multiply, I need to multiply 18.6 times 9, and that is 167.4 square kilometers. That's the area of the large rectangle. I want to subtract out of it that area of the circle, so I multiply 3.14 times 4.5 times 4.5, and I get 63.585 square kilometers. And finally, I subtract 167.4 minus 63.585, and I get 103.815 square kilometers. So the area of the shaded region would be 103.815 square kilometers.